Welcome to the final nugget, the Cisco CCIE Practice Lab. Now this nugget is going to be geared around a sampling of what a practice lab should look like, because practice labs can take you easily 8 to 12 to 16 hours depending on how long it is, how much research and study you have to do. Rather than go through an entire practice lab, which could be extensive, I'd like to give you kind of a piece of what one might look like or what you should prepare for as you're getting ready for that CCIE exam. Now, I went ahead and broke this down into four major areas, or sections as they're called when you start practicing: LAN and WAN configuration, routing protocol configuration, and advanced services configuration, which could include anything that Cisco can throw at you on routing or switching side of things if you're taking the routing and switching exam. So let's take a look at what the topology for this nugget is going to look like. Here it is, a pretty extensive topology and a pretty large topology. And that brings me to my first thought. Get used to drawing out topologies on large pieces of legal paper. The reason I say that is when you get to the CCIE lab, you will get huge pieces of paper, and I love them because you can spread things out. One thing that I really got in the habit of was condensing topologies, kind of like this, to where everything is smooshed down into a small area. If you have a large legal piece of paper, you can spread things out, jot notes, draw arrows, mark routers that are having trouble. All kinds of stuff can be fit in that topology. And that's the first thing that you should do when you get to the lab environment. Before you really do much, you need to read through the entire lab manual. Take a look at what they're going to have you do. And as you read through it, write down your topology, draw it out. You're going to have a notebook that has many different topologies in it showing each aspect of the network. You can combine most of the elements of all those different diagrams onto one huge legal piece of paper as you draw things out and as you jot notes as to what areas you're going to be configuring. For example, I drew out this topology showing the frame relay DLCs to connect to each end, the IP addresses that were initially given me in the lab example, but notice router 5 doesn't have any IP addresses. Well, that's because router 5 is my hub of this whole network. It wasn't pre-addressed as most things are in a CCIE lab. Rather, I'm going to have to come up with the sub-interface and the IP address scheme that makes this whole thing work. You notice down here that I have VLAN 63 with a little asterisk, HSRP, and an IP address. That's because I read through the lab requirements, and as I was going through, I saw, hey, they're going to have me configure HSRP. Here's what the IP addresses are going to be, and here are the routers that are going to participate in that. You also see I have no IP addresses assigned to those interfaces. The switches have the physical connections, whereas some switch connections, like you see up here, are a little more logical. This router is plugged into the same switch, but logically speaking, it's isolated in its own VLAN with this backbone 1 router. So I'm going to have to really plan things out, draw it out as I read those lab requirements. And so we begin with those lab requirements. Section 1, LAN configuration, 3 points. This is going to be exactly the format you're faced with when you're starting to get into that CCIE lab exam. You're going to see many sections, each one of them with a certain point amounts. In my experience, I have seen them range from anywhere on the low end of being 1 or 2 points for maybe a single or a couple objectives, all the way up to 5 to 7 points for a huge section. The big catch that you have to have is under each section is a number of objectives. In order to receive the points, you need to complete, to the satisfaction of the Cisco proctors, every single one of those objectives exactly as it's stated. If one thing is off, you will lose the points for the entire section. It doesn't matter how small it is. One of the things that they negated a few years back was that they completely negated partial credit because people began arguing, hey, this kind of puts the proctor into the ball game, saying that, you know, this one may think this is worth 3 points, this one may think it's worth 4 points. It's kind of an objective thing. Instead, they made it subjective, saying you either get it all or you lose it all, which has its advantages, but also has its major disadvantages when you know all 9 things in there, but that 10th thing, can't remember how to do that. That's where it really hurts. Here's the LAN configuration and the objectives. First, we need to configure an 802.1q trunk between the 3550 switches and utilize Ether channel to maximize that utilization. That's down here between these switches. Then configure the VLAN trunking protocol. Switch A should be the server, B should be the client. We should have Nugget 2 as the VTP domain name and authenticate using a password of Cisco. Finally, configure all the necessary VLANs and port assignments so that I'll need to create VLAN 63, VLAN 40 over here, VLAN 51. Let them replicate and also assign all the necessary ports. Now, you can see, if you squint, on my topology, I have, for instance, on this backbone 1, fast Ethernet 2/0 dash fast Ethernet 0/1. That's the way I annotate things. Ethernet 0/0 slash fast Ethernet 0/4. So I can see not only the local interface, that's the first one, what the interface of the router is, but also what the interface is on the switch that I'm plugging into. When you are in the CCIE lab environment, you will notice as you bring up your connections that things are configured already. We already have host names on the devices. A lot of the options that like the console, logging synchronous, no exec timeout, things like that, many times you may find them already configured. IP addresses are also most of the time configured on the major routers. All of these we'll find are already assigned to the interfaces. And of course, in the practice lab, we're going to be doing a lot of that. Unfortunately, that typically ends up being what you are mostly doing on the practice lab, just so you can get to the level of learning the new objectives. Try to limit, that's one thing I found when I was studying myself, how much time I spent, first off, recabling before I figured out the frame relay way of doing everything. And also, the second thing is assigning all the IP addresses, changing my schemes as I change to a new topology, things like that. Try to limit the amount of time you're spending doing this sort of stuff and spend it on the more advanced topics. The reason why is Cisco has cut all of that out of the one-day CCIE lab exam. It used to be 2 days, and before, you had the time to cable, to address, and so on. They cut all that easy, the quote-unquote easy stuff out, and now it's just on the meat of the exam. All of the easy stuff has been done. So let's go ahead and work through this first objective that we see here. Configuring an 802.1 trunk between the catalyst switches and utilize Ether channel. Well, I'm going to get in, and let me flip back and forth between the topology. Interfaces, there's fast Ethernet 023 and 24 on the switch. So go under interface, fast Ethernet 0/23, and I will type in switch port, trunk encapsulation, and I'm going to use .1Q, just as the scenario tells me to. And then I'll type in switch port, mode, trunk. So I've now turned it on to trunking mode. Now while I'm under this interface, I might as well turn on Ether channel. I'm going to type in channel group, followed by the group number. And I'm going to type a number from 1 to 64. I'll just go ahead and pick 1 as my channel group. The mode will be, let's go ahead and turn it on because I don't like all the negotiable modes. That way we have an instant Ether channel being created as soon as I hit the enter key. So we have now created a port channel. Let's go into interface fast Ethernet 0/24 and do the same thing. Switch port, trunk encapsulation, .1Q. Switch port mode, trunk. So I have the trunking turned on. Now let me go ahead and type in channel group 1 mode on. All right, that is switch A. Now let's hop on over to, oh, that's the same switch. How about switch B? I'm going to go into global config on switch port and switch B. Get into the fast Ethernet, switch port, mode, trunk. Oh, I forgot to turn on the encapsulation. Let me go ahead and do switch port, trunk encapsulation, .1Q. Up arrow twice, switch port mode trunk. I'll go and put this one in channel group 1 mode on. You know, this would be a good time for a notepad document where we cut and paste all these commands. Interface fast Ethernet 0/24, switch port, trunk encapsulation, .1Q, switch port mode trunk, channel group 1, mode on. So at this point, we now have Ether channel connectivity and trunking connectivity between these two switches. And we should be good to go. I'm going to hop on over to switch A, and let's do a show Ether channel. Make sure everything's working. And we have group 1 ports in there. We have the port channels, the max port channels showing up. Let's go ahead and do a show detail on there. And sure enough, we have each one of the ports that shows that they're up, they're in the bundle. looks like we're good to go. No protocol, since we're not really negotiating anything. We're just saying it is on. It is in the state of always being on. So at this point, we've got our first objective done. Now let's go ahead and set up VTP. I'm going to go ahead and clear off the screen of all this gibberish. And we'll go into, first off, global configuration mode. Configure terminal. So I'm now in global config. Let's go ahead and type in VTP, question mark. Got to use the context-sensitive help. Switch A should be the server. Switch B should be a client. Now the default mode is server, but I'll go ahead and type in VTP mode server, just to be sure. Then I will type in VTP domain nugget 2. Remember, if the lab has it all in caps, use all caps. Something as big as lowercase, uppercase can come back to haunt you. Then I'll also type in VTP followed by password, and we'll set that password to Cisco. So we now have the VLAN database configured with the correct name, the correct password. I'm going to hop on over to switch B, get into global config. I'll type in VTP mode. Well, actually, before we change the VTP mode, let's go ahead and do all the settings, because client mode won't let you change anything. We'll do nugget 2, VTP password, Cisco, VTP mode client. So at this point, we should have the VTP configured and communicating between each one of these switches. Let's hop on over to the server. I'll do a show VTP. See if they have a, oh, no summary command. Let's do a show VTP status. That's what it is. VTP status, we are currently at config rev 0. We haven't created any VLANs. Maximum VLAN supported locally. Nugget 2, we have operating mode server. Looks good to me. Okay. Well, let's go ahead and it says VTP domain name, authentication. We have the switches. Let's go ahead and set up the VLANs and then make sure that everything is replicating using VTP correctly. We have VLAN 51, VLAN 63, and VLAN 40 are the ones that we need to create according to the topology. Global config, VLAN, I just read them, don't remember them. 51, VLAN 63, VLAN 40. I remember that one. So at that point, we've created the VLAN. So if I do a show VLAN, I didn't assign any names to them at all. I just have the individual VLANs, VLAN 40, 51, and 63. And it looks like I have a few other VLANs that I had created previously on the switch. That's okay. And again, if the lab doesn't tell you to assign names to them, you can or you cannot choose to assign names. It's totally up to you. So at this point, we should have the VLANs configured. How about the port assignments? Now, not shown in this topology, but every single one of these devices are connected to switch A. So what I need to do is go on switch A and assign each one of those ports to the correct VLAN. So I just need to look at the topology and see right here we have fast Ethernet 0/1. Oh, I didn't annotate it on here, but it's fast Ethernet 0/5, fast Ethernet 0/4. Each one of these matches up to the switch port that I need to go under. So I'm going to hop into my switch, go under, let's go ahead and start off with the router 5. So I'm going to go under switch port, interface, fast Ethernet 0/5, switch port mode access, followed by, or actually, switch port access, VLAN, followed by, in this case, that port is going to be on VLAN 51. Then I'll go under interface fast Ethernet 0/1. Hit the up arrow. That's also in VLAN 51. Fast Ethernet 0/4 is VLAN 40. And so on and so forth. Let me get these two guys over here into the correct VLAN, because we'll use that for HSRP. 0/6 and 0/3 go into VLAN 63. 0/6, 63, 0/ oh, what have I done? All right, let me get back over to 0/6. Get that in the right VLAN. There we go. So now when I do a show VLAN, I should be able to verify that all the correct ports are in the correct VLANs, and it looks like they are. So at this point, we should be good to go. Only one last thing to check is going to be, have all our VTP updates replicated from switch A over to switch B because of the VTP configuration. Well, let's go check it out. I'm going to hop over to switch B, do a show VTP status. And that is good. VTP configuration revision has gone up, even it's in the client mode. So that means it has received some updates. So I'm going to do a show VLAN, and we should see the same VLANs over here. Sure enough, we do. They have replicated over from switch A, and this verifies not only that Ether channel is working correctly, because if that was misconfigured, our trunks would fail, but also that trunking is working correctly, and VTP is replicating with the correct domain name and authentication name. So that just got us 3 points. We have our LAN configuration complete. But the LAN configuration is how you'll usually start the exam. It's a nice, easy, in my opinion, I think the LAN configuration is easier than the majority of it, but it's a nice, easy way to ease yourself into the test, because you're just going to be creating VLAN, setting up Ether channel, VTP, that kind of thing. Should be a nice, smooth start for you. From there, we move into the more difficult concepts. Section 2, WAN configuration, 5 points. We need to configure a partial mesh frame relay network between router 5, 6, and 3. Router 5 and router 4 should connect on the frame relay network using their own subnet. Now, it doesn't tell you, but that immediately hints to you, 5 and 4, they're probably a point-to-point sub-interface. Oh, but then it says, do not integrate backbone 2 into the network at this time. That's this guy right here. Sub-interfaces can only be used on router 5. I hate it when they do that. It's something you would never be forced to do in the real world. However, the CCIE exam is going to limit as to what methods you can use to make all this work. The reason why is Cisco knows later on when you get to routing protocols like OSPF that just behave strangely over frame relay, if you are to configure everything as a point-to-point setup, which is the ideal, it would work very easily for OSPF. They don't want it to work easily. They want to throw a fork in your gears. So that's why a lot of times they'll limit the methods that you can use. So with that in mind, sub-interfaces only on router 5, all of these are going to use the physical interface. That tells me this is going to be a pretty big multi-point style of configuration, since you don't really have physical point-to-point sub-interfaces or physical point-to-point interfaces on a frame relay network. From there, we configure ISDN backup on router 5 and router 6 to take over in the event of a frame relay failure. So let's make it happen. I'm going to bring up the router connection, and we're still sitting on the switch. So let's hop on up to and flip back to topology. Let's start with router 5. Router 5 is the hub, so let's get it going so as we connect all the rest of them, we'll see those connections become active. Now, they typically will not let you have access to the frame relay switch in the middle, and the frame relay switch will be feeding you a ton of bogus DELC information. They usually have a full mesh configured or at least some kind of wild partial mesh, and if you let frame relay configure itself with all the inverse ARPing, you're going to end up with a huge mess. So the first thing you need to do when you jump on router 5, so I'm going to go, let me actually flip back, under serial 1, I'm going to go under that physical interface serial 1, and I'm going to type in no IP address, make sure there's nothing under there, encapsulation frame relay, and I'll do a no frame relay inverse ARP. I'll also do a no ARP frame relay. It's also a redundant command, but I do it just for safety. So what I have there is I have now, it will not try and figure out who's on the other side when it gets the DELC list, and also it will not let the other side figure it out. That's what those two commands do. So I've turned that off, so when I type in no shutdown, I'm not afraid at this point to receive a ton of bogus DELC information because it's not going to start making the mappings dynamically. So I've got my encapsulation frame relay. Let's plan out this a little bit. I don't have any IP addresses jotted down here because it looks like it says router 5, 6, and 3 should be all on a partial mesh. So that tells me that's one network. Multi-point network. Router, where are we? Router 5, 6, and router 3. So squint, 175.10.16, 175.10.4. So I'm thinking this one, let me go ahead and grab my little miniature pen here. I'll type over here, since I can use sub-interfaces on router 5, I'm going to make S1.1, and we will make that 175.10.16.5. That will be our sub-interface to connect to those guys over here. So let's go ahead and create that. And that's what I'll usually find myself doing is I'll jot it on the diagram, go create it. interface serial 1.1, and it'll be a multi-point. So I'm under that subinterface config. IP address 175.10.16.5. All right, so we have the IP assigned. I'm going to do a frame map, frame relay map, IP 175. See, oh, by the way, I did this for a reason. You saw what I just did, right? I just typed in frame relay map, IP 172.16 or something like that. Commonly, that's what'll happen is you'll end up with lab requirements that tweak the private address ranges that we're so used to using. So a lot of times you may find yourself typoing things because subconsciously you're thinking 192.168 or 172.16 or 10. So carefully read those IP addresses. I'm going to map the IP address 175.10.16. Let's go ahead and do .10. And the delc will be, well, it's 506. It's kind of cut in the middle, but that says delc 506. And one thing you'll always want to get in the habit of is allowing broadcasts to go across that line, or else your routing protocols will not work. I'll hit the up arrow and create the mapping for the other guy, 172.16.4, and that goes down 503. All right, so we've created our two mappings on router 5. Now let's focus on the other requirements. As router 5 and router 4 should connect over the frame relay network on their own subnet. Now, immediately I think, oh, point-to-point subinterface. But what ends up happening is, let me get my pointer here. If I create a point-to-point subinterface on router 5, which is completely legal, I get over to router 4 and I can't create subinterfaces. I don't have that point-to-point capability. When I think of things like that, you can make it work, but OSPF will behave differently if configured on a physical interface as it would on a sub-interface, specifically a point-to-point sub-interface. So what I'm going to do over here on router 5 is I'm going to create serial 1.2. Let's check this IP, 175.10.34, 10.34 dot, and that one's .8, so I'll make this .5. Just to match the router name. So I've got, there we go, the IP address that's assigned to that subinterface, and I'm going to configure that now on the router. I'm going to do interface serial 1.2. I'll make it a multi-point subinterface because that is going to be more compatible if I configure the physical interface as router 4 without using any subinterface. And I'm thinking of the OSPF network modes. I'll do IP address 175.10.34.5, and then I'll do a frame map, IP 175.10.34.8 was the other side, and that is going down delc 504. Gotta allow those broadcasts. Groovy. So at this point, I'm going to do a Control-Z, do a show IP interface brief, and we should see right here, we've got serial 1.1 and 1.2. Looks like Ethernet 0 went ahead and brought itself up because I have a DHCP server connected to that network, and I'm going to fix that right now. No IP address, and we'll just do a shutdown on that for now. All right. So I now I've got that interface corrected, and right now it shows that this one is up currently, and it looks like, and it just go back down. It's staying up because it looks like the other side should have an up interface. But if we see down, down, not to worry as of yet because we haven't configured the other sides. So let's hop on over to router 6, router 3, and router 4 and set up their sides of the picture. So I'm over on router 6 at this point. Let's go ahead and clear the screen off. Nice clean slate. Do a show IP interface brief over here. And it looks like I'm still grabbing that DHCP address. I'm going to go under interface Ethernet 0, no IP address, shut down. Serial 0, if you notice, this is a lot of times how you'll end up seeing it, already has the correct IP address assigned, but the interface hasn't been powered up yet. So let's go under interface serial 0, no shutdown, and cat frame relay, no frame relay inverse ARP, no ARP frame. So I've turned off all of the ARPing to make sure I only get the correct LC. I have the IP address already there, so I'll just need to do a frame map IP. I'm under the physical interfaces because of my lab requirements. Map IP let's see, 175.10.16.5, and we use del C 605 to get there. Map IP 172, 175.10.16.5, and we are using 605 to get there. So I'll type that in, and I now have a good connection there at that point. Let me do a show IP interface brief, and it looks like we've got connectivity at that point. Now, one thing that I'm going to do is while I'm here, well, you know what? I'm going to save it. I'm going to save it for when we get to the routing protocols because we haven't read that far yet. Section 3 will change things a little bit. So I'm going to go under, let's look back at our topology, router 3. Do a show IP interface brief over here. There's our serial 0, has the correct IP, is shut down. So I'll do interface serial 0/0, no shut, and cat frame, no frame inverse ARP, no ARP frame. So at this point, I now am good to go on that interface, and I just need to do my frame map, 175.10.16.5 to del C. Let's take a look at that. 170. Oh, did I type 172? Good. 175.10.16.5 to del C 305. Broadcast. All right. At that point, we should be good to go. I'm going to hop up to router 5, do a show IP interface brief. I'm going to do a show frame relay map. And we have, sure enough, my mappings, 503 and 506 are mapped to that interface. They are both active. So at this point, we should be able to ping the other sides. I'm going to ping 175.10.16.4. Good to go. .10. Good to go. All right, so at this point, we've brought up router 5, 6, and 3. And the requirement said allow router 5 and router 4 to use frame relay using their own subnet. So let's set up router 4 on that other side to connect to router 5. So I'll bring up that connection, hop on over to router 4. Hit Control Z, let's do a show IP interface brief. There's our IP address, it's already been assigned. Now we just need to go under there. Can't create sub-interfaces, so interface serial 0/0 on cat frame, no frame inverse. Trust me, these commands will become second nature to you once once you type them in so many times. No shut. The reason I do this a lot of times, no frame inverse and no ARP frame relay, is because in some versions of the iOS, if it dynamically makes those mappings, there's the command clear frame relay inverse ARP that's supposed to clear them all out. However, a lot of times that command does not work in some iOS versions, and I found that in the CCIE lab exam they can be mean to you and give you those iOS versions. That means you have to reboot the router to get those bad mappings out of there. So before you power on the interface, try and make sure that you at least have this command, no frame relay inverse ARP, typed in there to keep it from dynamically making all those mappings. It already has the IP, so I'm just going to do a frame map IP 175.10.34. Flip back over here, 34.5. And that is going to be using del C 405. Allow those broadcasts. So at that point, I'll do a show frame relay map. And we have all these del Cs that we've learned about, of course, never learning an IP address. Depending on the iOS versions, you may or may not get this del C list. But we have right here, del C 405, the current status is active. So we should be able to, let me just do a show IP interface, ping 175.10.34.5. And sure enough, we are reaching the other side. So at this point, our frame relay network is chugging along. ISDN backup. We need to configure this to connect router 6 to router 5 in the event of a frame relay failure. You know, the first place I go whenever I see ISDN in any configuration, I go straight to the one thing they give you access to during that exam, the Cisco connection documentation. Now, early on, when I was first getting to know the product documentation, I hated it. I was thinking, man, if I just had the CCO search web page, I would be fine. But of course, they don't let you have the CCO search web page. But I'll tell you what, it did me some good. After working with this thing and memorizing literally where most things were in the product documentation with the configuration, you get to know this pretty darn well. And I find myself in the real world a lot of times going, oh, forget the search. I'm going to go straight to the product documentation because I know where this is at. So what I usually end up doing is jump into the product docs and you will have access to this during the lab. It's typically either on a CD-ROM they'll give you, or now some places are allowing you web access, but limiting to you to only this page, some testing sites. I usually go to release 2.2 because 12.2 because 12.3 I find isn't fully written. It'll actually refer you a lot of times to the 12.2. Always configuration guides and command references. Truth be told, I really don't even know what all those other things are. Straight to the config guides, we have a bunch of configuration areas, and I would spend a lot of your time getting very familiar with each one of these areas. For instance, security is my weak spot. As I mentioned back in the voice, I learned voice over IP instead of security because I thought that would be much cooler. And in my opinion, it still is cooler. But I have this huge weak spot in security, so I find myself a lot of times jumping under here to say, okay, how do I do, for instance, traffic filtering? How do I set up a firewall? Lock and key, TCP intercept. A lot of these common security methods are given to you right there. In this case, though, we're going for ISDN, which, careful where you're looking. You might think interface, you might think wide area network, but this is located because it's dial. It's a dial technologies. Jump under here. You have dial backup, ISDN config, a lot of the different areas of configuration that we can set up. I'll choose ISDN, and we see that we have virtual asynchronous, ISDN BRI. The reason I bring this up, by the way, for ISDN anytime I hear mention is because there's so many nuances with it, so much that you can forget. So without even looking at this, you should know the syntax. You just need a good config example to take a look at to make sure you hit all the high points. So you jump under here, hit maybe like multi-link PPP. Right there, a nice clean config example just to give you all the high points to configure. Now I went under ISDN config, but remember we also had dial backup config. And I could say, well, I want to do a dial backup for a serial line. There's using ISDN as DDR. This gives you the specific dial backup commands. Doesn't give you any of the good stuff that we saw in the ISDN, all the PPP multi-link, PPP authentication, a lot of those. So if you're asked to do those, you may find yourself going to both places. But I would just refer to the documentation, keep it on the side of the window. Your monitor should support a nice high resolution so you can keep both windows open. Get your syntax up and running and start configuring that ISDN. Now in this nugget, I'm going to skip over this ISDN config because really it's kind of a plug and play. You're just going to plug in each of the commands with the correct numbers to dial. In the dial strings, type in the backup interface command to say that this is a dedicated backup, or whatever the lab has you do to consider that a backup interface, and you're good to go. So voila. I'm going to skip over that, and we just got 5 points. If only we could do that in the CCIE lab exam. And that brings us to section 3, the routing protocol configuration, 4 points. Typically in the CCIE lab exam, this will be where you spend the vast majority of your time. Look at the first step. Configure OSPF to run over the frame relay network. You may not use the IP OSPF network interface configuration command. As they do in typical Cisco fashion, they have limited the methods that we could use. By not using this command, that means we have to adopt whatever mode it accepts on that interface just out of the get-go. That's why, by the way, when I set up frame relay, and I said, I'll wait to tell you till now. When I set this up as a multi-point interface, because if we would have configured OSPF and I set this up as a point-to-point kind of connection, this side, which allows sub-interfaces, would have adopted the point-to-point configuration mode. This side, since we can only use the physical interface, will adopt, well, whatever mode all these are going to adopt. You remember which one that is? I'll test your knowledge in just a second. Unfortunately, the two modes that they'll adopt will not be compatible, and we can't change them because they've limited our use of this command. I hate it when they do that. So let's go ahead and bring up our Terra term, and I'm going to jump on router 5 and get into router OSPF 1. Let's check what mode it's going to do by default. And let me just do a show IP interface brief just to see my interface IP addresses. I'll do a network 175.10.16.5, and they didn't tell us what area, so we'll assume area 0. We'll have 34.5. By the way, if you're ever unsure about anything, if the lab isn't clear, Ask the proctor. That's what they're there for. They make those poor guys sit in there 8 hours a day just to answer those questions. And a lot of times they may be more helpful than they're supposed to. They're very kind gentlemen, I have found in my experience. So I've configured those two networks. I'll do, let me just do a router ID because I like just knowing where my routers are. And let's do a show IP OSPF interface. See what mode these adopted by default. Well, since they're multi-point interfaces, they took the network type of non-broadcast. Oh, NBMA. That means we have to statically configure each one of our neighbors. It won't dynamically allow any discovery. So in router 5, I need to go under router OSPF 1, and since all the other ones, they're all multi-point interfaces, so they'll all adopt that same one. That's good because our timers will be the same. Different network modes have different timers. And I'm going to type in neighbor. Router 5 is going to unite with 175.10.16.10. 175.10.16.10. It will also unite with 175.10.16.4. And with 175.10.34.8. So I have all those correct neighbor statements configured on those on the router 5, and now I need to come to each one of those routers and set up OSPF on them. Meanwhile, before I leave this router, let's look at the rest of our lab objectives. Let's make sure we're efficient here. It says configure EIGRP to run on all LAN interfaces in Autonomous System 5. That's something we can do. We're sitting at router 5. We might as well do it while we're here. We'll do router EIGRP 5. And I didn't assign an IP address to this interface, so let's go ahead and do that right now. I'll say for router 5, this will be 192.168.2.10/24 to be compatible with that other side. I'll say network 192.168.2.0. So I now have EIGRP running on that network. Interface Ethernet 0 is on this router, and I'll do a IP address 192.168.2.10. By the way, typically flipping back and forth like this isn't commonly done because you'll either have a lot of screen real estate or you'll have that huge legal piece of paper that you're referring to and writing these IP addresses on each time you assign them. I'll do a no shut over here as well. So I now have OSPF and EIGRP running on these two, and it says finally redistribute fully between both of these routing protocols. Implement filtering where necessary. Well, let's look at our topology. Let's see. If I redistribute OSPF fully into EIGRP and vice versa, it looks like it's not going to go too far. Backbone 1 seems to be the end of our network, so it doesn't look like filtering will be very necessary on router 5. So I should be able to go under router EIGRP 5, and I'll just do a redistribute OSPF 1, and I'll type in a metric. Let's do 1, 15, 15, 15, 15. You might be saying, what kind of metric is that? And that's a metric that I'll type in if they don't tell me what metric to assign, because I really don't care what the metric looks like to it on the other side, as long as it gets there. That's the main point. I'll go into router OSPF as well, and I'll do a redistribute EIGRP 5, followed by metric of, let's just set it to a fairly large metric, and I will type in subnets to filter the subnets through. Now, if you watched the OSPF nuggets, you'll notice that I always use tags when I'm redistributing it into OSPF, and this is going to be no exception. I'm going to type in tag followed by, I'll just say 5. That way, all of the EIGRP routes, as they're redistributed into the OSPF domain, all have this little coloring crayon of 5 on them. So all the routers will say, oh, hey, you're part of the number 5. And that way, when I'm coming over here, especially, look at this, router 3, router 6, they're connected to the same Ethernet LAN. We could have a loop by doing full redistribution. Same thing with router 4 coming into all these networks. I haven't fully analyzed this yet, but this could cause a loop. What I could do is I could just put filters on each one of the routers that redistribute from OSPF into EIGRP, and I can say each one of these routers do not allow routes tagged as 5 to get through. Or maybe down here I'll choose a different tag and say tag of 10. So I can say all the 10 routes cannot get through, so I don't have these looping routes going all around. If you haven't seen the tags before, definitely check out the OSPF nuggets because I go in depth in that explanation. Great way of filtering. So every time I redistribute into from EIGRP or into OSPF by anything, I'm always going to tag it with something. And it looks like my OSPF, my neighbors are all dying, and that's going from attempts to down because my neighbors have not responded, and that's normal. I have not configured the other side of the relationship yet. So let's hop over to router 6, and I will configure that other side. Let me look at the topology real quick here. We have router 6, OSPF neighbor to router 5, router 3 to router 5, and router 4 to router 5, each one of them with that single neighbor statement. But wait a sec. Before we go on, let's look at this topology a little closer and think. Router 6, router 3, and router 4 are all going to have OSPF running up to router 5. They're all going to need a neighbor statement that tells them about router 5. But let's think about the attributes of NBMA mode of OSPF. What does it assume? Well, it assumes that all the neighbors are directly connected together. It assumes the frame relay cloud looks just like an Ethernet segment does, where everybody can reach everybody. It assumes a full mesh. Now, we don't have a full mesh in this configuration. We only have a hub and spoke topology. Here's the problem that's going to happen. We're going to set up neighbor statements, and I'm going to say router 6 to router 5, router 3 to router 5, and so on. But it's going to start getting routes that have the next hop. For instance, router 6 will get routes that have a next hop of 175.10.16.4. Likewise, router 3 will get routes that have the next hop 175.10.16.10. It will not know how to reach those. IP OSPF network mode of point to multipoint will fill those cracks in. It will say, oh, hey, this is a multipoint interface. I'll fill in the individual routes that allows these two routers to reach each other. But in this world, NBMA, that's not going to happen. That's why they throw things like this at you, is because it's going to blow up if you just configure it as the textbook says. You need to realize, wait a sec. Router 6, I'll do a show frame relay map. It needs a map manually entered to reach 175.16.4. It needs a manual map to reach over there to router 3. And to get there, it's going to use Delcy 605, the same Delcy it's using to get to the hub of the network, since that's the only Delcy it uses. Likewise, router 3 is going to need the exact opposite map. Interface serial 0. Oh, that one's /0. Frame map IP 175.16. or 175.10.16.10 is router 6. And I'll use on router 3, sorry for all the flipping, Delcy 305 to get back there. So at this point, I'll do a show frame map. Router, well, this one has a bunch of empty maps, but the ones we care about down here, router 3 and router 6 should be able to ping each other directly. If you do not do this, and they can just by that test, if you forget to do this, the NBMA network will blow up. Routes that router 6 sends over to router 3 will get there. However, router 3 will reject them because it has an unreachable next hop IP address. That's one of the big gotchas when you're working with that NBMA mode. So for time's sake, what I'm going to do is I'm going to jump and I'm going to pause the video and I'm going to jump off and configure OSPF on each one of these spoke routers in order to connect back up to router 5. And I'll come back and show you that config. Okay, I went ahead and set that up. And let me bring up the demo window. I'm on router 5. I'm going to do a show IP OSPF neighbor. And what I have is 444, 333, 6666, all becoming neighbors with router 5. So all these, let me get to my topology here, router 6, 3, and 4, I gave them router IDs right after themselves, have become neighbors with router 5. Now if you notice, some of them are becoming BDRs on the different interfaces it's selecting, because NBMA mode considers that everybody's fully meshed. It treats it just like a typical Ethernet segment. This may or may not be true because we may or may not have full mesh. In this case, we don't, and there's the problem. If any one of these routers becomes a DR other than router 5, there's going to be a crisis in the network because the DR has to have full connectivity to all neighbors. So the first thing I want to do is go under interface serial 1.1 and serial 1.2 and type in IP OSPF priority 255 on both of router 5's interfaces. I'm going to clear the OSPF routing process, clear IP OSPF process, and that should reset. And that way we should guarantee that router 5 stays the DR. Anytime you say it became the DR just because it was the first one to come up. But if it was ever reset at any time and one of these other routers become the DR, that poses a major problem. What we would also need to do is hop on over to each one of these routers just as a backup. I'll go over to router 4 just to show you. Go under interface configuration mode for, I'll put serial 0/0, and do an IP OSPF priority of 0. That guarantees that this router will never become the BR or the DR because it always maintains its DR other status. So at that point, we have OSPF routing configured between all these, and I went ahead and set up EIGRP on all the LAN interfaces during that break as well. Now, the final thing is to redistribute between them, and I did that on router 5. Let me show it to you again just as a good review. I'll pick router 6, which is over here. I'm going to do a show IP interface brief to see router 6's interface, show IP protocol so that we can see both OSPF and EIGRP are running. And what I'm going to do is go into router OSPF 1, and I'll do a redistribute EIGRP autonomous system 5 metric. I'll just put 100,000 subnets, make sure all the specific subnets get sent to, and I'll do a tag. When it's coming from those bottom interfaces, I'll tag them with a 10. At that point, I now have EIGRP routes going into the OSPF system, and I need to go the other way as well. I'm going to go under router EIGRP. Here's what I want to show you. Actually, before I do, let me go under router EIGRP 5. My brain is pondering these things. There's multiple ways that we can filter those routes. I'm going to go under router EIGRP 5, redistribute OSPF 1. Let me go ahead and set the metric. I'm going to say metric is going to be 11111. Just get all those 5 different EIGRP metrics in there. And I'm going to say match. Now, I could use a route map to allow only the routes that match a non-tagged route in. Or I could say only match tag 5, which is coming from up here. But in this case, I'm just going to say match the types of route that are internal. There's another way of filtering, one of my favorites, because what that does is it says only send routes that are inter or intra-area OSPF routes into the EIGRP system. These routes that I'm sending from EIGRP, those are going to be tagged as 10, and they're also going to be external routes. So when I come in here and I say match only internal routes, it guarantees that only OSPF routes that originate in this system will end up being redistributed down here. Now that can be a problem for these routes up here because those will be marked as external routes. That's why you'll also need to, actually this way would come short, matching the internal routes. Because I would need to, instead of doing a match internal, I would have to do an up arrow, do a no redistribute, hit the up arrow again, and this time instead of doing a match internal, since it leaves those ones up top short, I'm going to do a route map, and I'll name it EIGRP to OSPF. And I'm going to exit out and do a route map, EIGRP. Oh, I guess it won't figure out the name if I do a tab because it's what I created. So I create that route map, and what I'm going to say here is match. I'm going to say the route type of internal. That will be my one match statement. And then I'll also do a match tag of 5. Oh, this is so awesome. I'm going to exit out and do a show route map. And what we see here is I have a route map that says EIGRP to OSPF. This is my filter for redistributing EIGRP routes into OSPF. And I'm saying that I am only going to allow routes that match of type internal and also routes that match tag 5. As a matter of fact, it's going to be an AND statement. I would create instead two separate sequence numbers that have each one of these match statements underneath them to do the OR kind of combination. But that's the idea. I would need to create a route map that keeps routes from looping around the system and ending up back into OSPF, or else you're going to have routes that show up in your routing table as potentially unavailable. That is how you can implement filtering on that OSPF and EIGRP network. Make sure you keep those loops from occurring. And that finally brings us over to section 4, the advanced services configuration 4 points. Now again, realize that I'm just making up these point values and so on. In the CCIE lab, they'll have their specific point values. The goal again of this nugget is to give you an idea of each one of these styles of configuration and what to expect from each section. You're going to be doing a lot of practice before you go in there, hopefully. So you need to get used to kind of this format. Now right here it says configure HSRP between router 6, router 3, and switch A. Wow. Use 175.10.11/27 for the HSRP address. All HSRP communications should be authenticated using NU993T as the password. Router 6 should be the primary unless the serial interface is lost. So this guy should be the primary one to respond to that virtual address. Router 3 should be the secondary, which is over here, unless its serial interface is lost. Then switch A should act as the final backup. So switch A will need a virtual interface for VLAN 63 that is able to respond for the HSRP requests. By the way, I like throwing this kind of stuff in there because this may be something you never ever do in the real world or have never done in your practice. It's one of those things that they expect to catch you on the CCIE exam because you're going to say, oh my gosh, I've never done that before. I wonder what that looks like. And I'll tell you what, when you get it running, it is the best feeling in the world to see it working on the IE lab. All right, so let's go ahead and do this. I'm going to bring up TerraTerm. Oh, and let me get it back in the window here. I'm going to have router 6 is going to be the first one that I'm sitting on, and I'm sitting on there right now. Let's go ahead and set that up for HSRP. So I'm going to bring this up. Let me go ahead and clear that screen off, clear buffer. And I'm sitting on router 6. What I want to do is a show IP interface brief. There's my Ethernet interface. Let's get underneath there. I'll go interface Ethernet 0. And to set up HSRP, I'm going to do a standby group. And I'll say this is, sorry. It's just standby 1. I'm thinking it is a standby group. However, I just typed in the group number. So I'm going to type in standby 1. And the first thing I want to do is assign it that IP address. I'll do IP followed by 175.10.11 with a 27-bit mask. Where's my TerraTerm? There we go. 175.10.11. I'll go ahead and hit enter. Now also, one of the things I didn't do was when I assigned the IP addresses to these interfaces, I didn't jot them down. Let me do that real quick. The IP address over here is 175.10.1.6. I just followed the same scheme. But right now it has a 24-bit mask. So in order for HSRP to adopt that, let me go ahead and give it a 27-bit mask. I'll do IP address 175.10.1.6, 255.255.255. I'm thinking of a 27-bit mask in my head. That would be 192.224. So at this point, I should be able to do a show IP interface brief. I've got the same IP address, good to go. Now I have the correct mask on there. Let's get back underneath there. I'll do interface Ethernet 0, and I'm going to type in standby group 1. And let's go ahead and give this one a priority of, we'll say 100, because it's going to have the top priority. From there, I'm going to type in standby 1, and let's give it a preempt, because that will allow it to come back. If it gets its serial interface back, it will automatically become the designated router again for HSRP, the primary router, and it'll boot any other ones that are on there back down. And then I'm going to type in standby 1 track, because it says right up here, unless the serial interface is lost. So I want to make sure that I track serial 0, and I do that and decrement the priority. Let's say I want to decrement that priority by 1, well, let's do 99. So it goes down to a priority of 1 if it loses that serial interface. So at that point, it should drop down below what the other ones are set at. So now I've set up HSRP on router 6. Let's jump on over to router 3. Because router 3 should be the secondary. Let's look at where that is. Oh, router 3 is right here. It has the IP address 175.10.1.3, and it's 24-bit, so let me change that over. Interface Ethernet 0/0 here. IP address 175.10.1.3, 255.255.224. All right, now standby. Oh, and it's going to cause it to renegotiate its neighbor relationships. I'm going to do a standby 1 for standby group 1. Let's do the IP address first. 172 or 175.10.1.1. That's the IP address that it's going to respond to. Standby priority will be, let's do 75. Just less than the router 6 we just configured. That way it'll be the secondary. And if I'll do a standby 1 track serial 0, or it's actually serial 0/0 while I'm thinking about it, and we will also, if it loses its serial interface, decrement it by 74. We'll drop it down to 1 there as well, so it becomes very undesirable. I'll do a standby 1 preempt to make sure that if it does come back online and it needs to be the primary, it can become the primary. And at that point, we should be good to go there. Cool. Now let me jump on over to switch A. Switch A should be the final backup. So what I need to do on switch A is create an interface for VLAN. This is VLAN 63. Now remember, as soon as you create that VLAN interface, it acts just like a real interface would on a router. I'll give it an IP address, 172.175.10.1. And 6 is used, 3 is used. I'll go ahead and just give it .2. Put it in the same subnet as everybody else. And from there, and just make sure I do a no shut. Standby 1 IP 175.10.1.1. Standby 1 priority, and I'll give this one a priority of 50. Standby 1 preempt, so that way if it ever realizes that it has the highest priority, it will become the primary router. And in this case, we don't need to do any tracking, because it doesn't have any serial interfaces that can go down. It will become the final gateway of last resort for VLAN 63 for HSRP. So all the clients on this network will be able to get there and reach that gateway, 175.10.1.1, in the case that any one of those routers is down. They're all acting now as backups for each other. So at that point, we've just gained 4 more points. HSRP is now configured between those 3 routers, or 2 routers and a switch with router capabilities, and we should be good to go. In this nugget, we have taken a look at a sample practice lab. Again, not at all meant to be an exhaustive discussion of Cisco technology. As a matter of fact, I really didn't want it to be too much about Cisco technology at all. I just wanted to give you a good idea of what a practice lab would feel like and should feel like when you're preparing for the real CCIE. That is nearly exactly of how it will feel in the CCIE lab exam, except you'll probably be a little more nervous. Your sections will be a lot bigger, have a lot more challenging things that can take some time, and they'll also have scenarios that counteract each other, as in you'll have to go back to one of the earlier scenarios to fix what scenario 4, section 4, did to your network. So all of these things, remember, each one of these little examples was just meant to give you a taste of what that would feel like when you jumped onto the actual CCIE exam, and kind of how you should be gearing your practice labs to feel. I hope this nugget has been informative for you, and I'd like to thank you for viewing.